Hello everyone. Let us learn about graphs in this lecture. Okay. I hope you can see some pictures on this board, right? Are these the graphs? Exactly. There are some examples of graphs. Okay. So if we observe that, we can see a points with white color one and a lines with red color one here. Okay. So let me explain about this first. So here there are some points and there are lines connecting these points, right? So we call these points as vertices or nodes. So we denote these points with VIs. VI, I mean vertex. Vertex I. We can call it as a node also. We can call it as a node or we can call it as a point. But most of the time we use this vertex. Okay, we call it vertex, and we can denote these points with v1, v2, v3, v4, like this. I'm giving some names to these points. Okay, so there are total 7 points are there. So there are 7 vertex here, and you can see the red lines connecting 2 points here, right? So you can see that this line is connecting V1 and V7, right? So we call this line as an edge. Okay, and we are going to denote this edge with a notation like this: V1 comma V7. So this edge is represented by this notation V1 comma V7. Similarly, suppose if I denote this edge with E2, how do you represent E2? E2 is an edge which is connecting V7 and V2. Similarly, you can think about the other edges, right? So now a graph is nothing but it is going to have a non-empty set of vertices and edges. So this is one example, and I hope you can see one more example here, right? How many vertices are here? Now you see the vertices. These are the vertices. 1, 2, 3, 4, 5. Okay, so there are 5 vertex. Okay, let me name it like this: A, B, C, D, E. It is not mandatory that you need to uh, name it like VI. Okay, we can assign numbers or we can use alphabets. Anything is fine, right? So here you can see that the interesting thing is between any two vertices, you can always find an edge, right? If I take A and D, there is an edge. You can see that there is an edge which is connecting A and B. Here is one, and similarly AD you can see. So this is what AD, right? Okay, this is one more example in which there are 4 vertices and 4 edges. Now I can have a one more graph like this. That's it. This is a graph. Now you may ask me, where are the edges? Okay, there are no edges in that graph, just a vertex set. This is independent of this. I mean, there is no connection between the guys. Okay, so this is also an example of a graph. And we have a name to this graph. We call it as a null graph. Okay, or an empty graph because there are no edges, right? So now we can look at the definition of graphs. So a graph is nothing but a non-empty set of vertices with edges. Okay, where V is a set of vertices. Moreover, this is a non-empty set. And E, this is set of edges. Okay. So now, okay, there is one more vertex I'd like to discuss. Not vertex, sorry, edge. So here you can see that this edge is connecting V7 and V1. Now we can have one more edge like this. Yeah. What is it? Now this edge is connecting V1 to V1 itself. Okay. Now we are going to represent it like this. V1 comma V1, and we call this edge as a loop. Okay. So we call an edge which is connecting a vertex to the same vertex as a loop. Okay. Loop, it means it is an edge connecting one vertex to the same vertex. All right. Now let us, so I hope you understand what are vertices and edges in a graph. Okay. Now here, if you observe that there is no direction assigned to any edge in these graphs. These are actually undirected graphs. So we can have directed graphs. For example, here if I assign direction to this edges, then it becomes a directed graph. Okay. But we are going to denote an edge not with this notation now, if it is a directed graph. Why? Because let us say I am naming this with A, B, C, D. Okay. Now there is an edge starting at A and going to B. Okay. So that edge, let me name it as E1. So now E1 here is denoted with an ordered pair A comma B. Okay, we denote with an ordered pair A comma B. Similarly, if I name this as edge 2, E2, how do we denote E2? E2 we denote it with an ordered pair, that is BC. Okay, similarly, let me name this as E3 and E4. So E3 is nothing but an ordered pair D comma C. And similarly E4, so that is an ordered pair D comma A. Okay. So this is what an example of a directed graph, and this is how we show an edge. I mean, we represent an edge in a directed graph. In an undirected graph, we represent it like this with a set notation, whereas in a directed graph, we denote it with an ordered pair. Okay.